So this answers the standard. I can calculate beat and Doppler frequencies. And it's problem 74 from chapter 16. No, not 74, 71. A man marries a great Wagnerian soprano, but alas, he discovers he cannot stand Wagnerian opera. In order to save his eardrums, the unhappy man decides he must silence his lark wife for good. He plans to tire the front of his car and send car and soprano speeding toward the brick wall. The soprano is quite shrewd, however, having studied physics from student's days at the music conservatory. She realizes that the wall has a resonant frequency of 600 hertz, which means that if a continuous sound wave of this frequency hits the wall, it will fall down, and she will be saved to sing more solides. The car is heading towards the wall at a high speed of 30 meters per second. A. What frequency must the soprano sing so the wall will crumble? So to do this, I just use the equation for Doppler. That this was the easier way for me to remember that we went through in class. So I said the frequency of the listener is equal to the speed of sound minus the velocity, or times frequency of the listener times the speed of sound minus the velocity is equal to the frequency of the source times the speed of sound plus the velocity. So that's 600 hertz plus or times 340 meters per second minus 0 meters per second, and then because the listener is the wall, and then the frequency of the source times 340 meters per second plus 30 meters per second, which after we did the algebra simplified to 551 hertz for the frequency she'd have to save to crumble the wall. Then the second part of the question asks at what frequency will the soprano hear reflected from the wall before it crumbles. So now rather than, well, it's the same equation, it's just the listener and the source are changing. So then the frequency of the listener is equal to 340 minus 30 meters per second, and that's equal to 600 hertz because that's the resonant frequency of the wall, times the speed of sound plus 0, and with the algebra that simplifies to 658 hertz.